Hi everyone, myself Hitesh, and welcome to droidCon APAC. Today we'll be discussing on a very popular topic, basically, from an Android developer's perspective, because shared preference is something that is very much close to every Android developer. So right from day one or probably day zero, we have been using the shared preferences, and now suddenly there is a change in the data storage thing. Like Android has come up with a different solution that is the data store. Let me introduce myself. Myself Hitesh. I am the technical architect leading the Android team at OLX Group. Roughly more than 10 years of experience into hands-on experience into mobile application development. So without wasting any time, so let's start. As a content, like today we'll be discussing what is Jetpack Data Store, what's it's under the hood, why do we need data store, setting up the Android project with the preference data store as well as the prototype data store. These are basically the two types of data store that we have. And finally, we'll also see how we can migrate from shared preference to data store. So let's start. So if I talk about the introduction, so if you see it's a part of Android Jetpack, and as the name suggests, it's a data storage solution. Comes with two different implementation. One is the preferences data store that stores the key value pairs. It's almost on a similar ground that shared preference executes. Second is the proto data store. This is something that is very important because it lets us store type objects via protocol buffers. I'll let you know what protocol buffers are for all those who are very new to this term in the later slides. Third, it stores data asynchronously, consistently, and transactionally. So by this, we can assume that our data is basically saved in an asynchronous manner or probably read in an asynchronous manner. The operations are consistent and also transactionally they are safe. Data store is ideal for small, simple data sets and doesn't support partial updates or referential integrity. So they don't support that database integrity and all this stuff. But yeah, it's very much ideal for simple and small data sets. So what's under the hood? So under the hood, both preference data store and proto data store saves the preference in a file. It's similar that our share preference does right now. And it performs all the data related operations on dispatchers.io. It's a coroutine dispatcher.io unless specified otherwise. So we can specify the dispatcher, we can specify basically on which thread it should run or something like that. But yeah, by default, it runs on the background thread, the IO. As far as saving the data is concerned, preference data store, like the shared preference, has no way to define a schema. So there is no schema, like it's a kind of flat, you can say, data that we use to save. And also we can't assure that the keys are accessed with the correct type. So the keys are also not defined properly in terms of if you say about the preference data store. For proto data store, it helps you define a schema using a protocol buffers, allowing persistently storing type data. So whatever you want to save is basically strongly typed, and there is a particular schema which will help you to identify the type of the object that you are basically saving into your preferences. DataStore also provides efficient, cached, when possible, access to the latest durable persistent state. The flow will always either emit a value or throw an exception encountered when attempting to read from the disk. So one of the major advantage of data store is basically it can be cached. So what happens is like there could be a case where because we used to query the shared preference in a synchronous manner. So most of the apps queries the shared preference in a synchronous manner. And what happens is like whenever there is a huge chunk of data stored in preferences, so sometimes it contributes to the basically the launch time or probably the performance time, load time of the page. So what data store helps us in this is basically whenever you require an asynchronous operations to be performed on your preferences, you can just call the data store asynchronously. The data will be cached, and then you can call the data store synchronously. So this is the beauty of data store that gives. So under the hood, as I told you, it's a kind of dispatcher.io that performs the background operations and returns a flow. So coroutine flow, it returns a coroutine flow, which you can basically get the data from the flow, and probably you can manipulate that. We'll see in a live example how we used to do that. So why do we use data store? But what happens is like whenever we have a shared preference loaded with data, it might result into some ANRs or probably the load time issues, and it is not main thread safe. So what DataStore provides us, on the other hand, it supports asynchronous via coroutine and flow, and is safe to use in the UI thread. It can signal errors and is safe from runtime exceptions. So all those parsing errors probably that we get in preferences while reading the preferences, while basically transforming the saved data into some POJOs or something like that. So it has a proper signaling mechanism where it will notify the consumer about all the errors. As I told earlier, it is type safe. The protos are type safe. And also it's faster, smaller, and simpler, and less ambiguous than XML and other similar data formats. So these are some of the criteria which we should consider while we're going for the data store. Like if we need to debate on why we need data store, probably these are some of the key factors that we consider while using the data store thing. Now let's see some code. So in preference data store, like I will just move to my studio where ID. So I'll give you steps by steps how you can configure the preference data store in your project, Android project. Now, first and most foremost thing is basically the setup thing that you need to do. So what is the basic setup that you need to do for this? You need to basically add the dependencies for the data store. Right now, the alpha, right now the alpha, well, alpha, basically it's right now it's in alpha, and alpha 5. So alpha 5 is basically alpha 05 is the latest release that you can see in the developer side. And for lifecycle and live data support, and also it supports lifecycle events. So you can map your data store to your lifecycle scope. So these are the dependencies. So my personal favorite is basically using data store with live data and lifecycle support. So if you want to add that, you can add in your dependency file. Now, going forward, after you add these dependencies, first of all, you need to change the compile version to 1.8 and also the Kotlin options JVM target version to 1.8. Now, let's see how you can add or probably add data store to your app in a sequential manner. So for using the data store, I will give you just a comparison of the existing shared preference and also the data store, basically to have a clean idea about how we can configure that. So while we use the shared preference, we used to have we define a shared preference, like we get the shared preference object, probably give it a mode or probably give it a name. In a similar fashion, for data store, we need to create a data store instance. So it provides a data store instance, and it takes the name of the file that you need to save. After you create the data store object, you need to define some keys. So in shared preference, what we do is basically we simply define a particular string and probably map that string to particular data, right? So likewise, we need to define a key, and that key is basically being given by the preference key, preference.kt class. There is a inline function, preference keys, where you define the preference keys. So for this sake, the use case that I'm considering is basically one of the use case where I need to show user the number of times a particular screen is launched. So I'll show you the demo. So for that, I'm saving a launch counter. Now, how do I save this value to my app launch counter? So there is the function edit. So suspend function edit. As you can see, it's a suspend function. So hence, this has to be run in a background thread. So there is an edit function. You first call the edit, as in shared preference, we do shared preference.edit, and then probably we write the value to that particular key. Similarly, you need to basically, since our use case is basically we need to increment the counter every time the screen is launched. So what we do is we read the preference counter and probably increment it by 1. And that's it. You basically just saved it to your uh, preference data store. For the consumer part, if you can see, we have a flow that basically gets emitted whenever you are reading from the data store. So here you can see we are getting all the data. We are mapping it. We are using the map function over here, inline function, map inline function, and therein we are returning the preference key to the consumer. And this preference key is being returned as a flow. Similarly, the deletion part or probably the removal part works as that of the shared preference, where you used to edit the data store, you get the preference object, and just call simple remove the counter. So these are the 4 steps or probably 5 steps which will give you the CRUD operations: create, read, update, and delete. So these are all the CRUD operations that you can perform using the data store. Now let's see, this is the data store. Now I will show you how we will read this value. So as you can see, it's a very simple project. So where there is a button which basically launch a particular, there is basically, I'm using this repository, and inside this repository, I am observing the launch counter. So whenever I'm observing this, I'm observing it as a live data. And whenever I'm observing this, I'm getting the counter in this observer. So now, as you can see, the screen is launch time by till now is this number. So this is how you read it from the database, from the data store. Sorry. Now for the button reset, what the button reset does is basically clear the appearance counter. And if you see the clear appearance counter is basically the removal thing that I have talked in the previous slide. Going ahead now, so these are all some of the steps that I have already described in the ID. Okay, so one important thing that you can see is basically the file that gets created. So whenever you create a data store preference file, so whenever you will go to your device explorer and probably go into your package, so there you will see a data store folder or package inside the files directory, and inside it you will find your app preference, the like file of the data store. So the name, that same name that you have given in while creating a data store object. These are all about reading, removing, and how we can consume the data from the data store. Now comes the big part, that is basically the protocol buffer. So what is protocol buffer? So protocol buffers are Google's language neutral, platform neutral, extensible mechanism for serializing structured data. So they are basically data storage solution to be defined in a very nutshell, in a nutshell. So it currently supports generated code in Java, Python, Objective-C, C++. So these are widely accepted, and it can support generate code in all the major languages of development. And on the top of this, these are very small in size in compared to JSON or probably in compared to XML. These are very small in size. These are very light and they're platform neutral. One of the major advantages of protocol buffer. Now, the setup part. So for protocol buffer, you need to have data store core. And the version being that is being used for the demo is basically the Alpha 02. Right now it's Alpha 05. And along with this, you need to add the protobuf plugin. So below you see the protobuf plugin where you need to add the generate proto task, like task in the Gradle, where it will convert your protocol file into the protos in the protocol protos. So data store dependencies is one of the things that you need to care of. Second is basically the protobuf plugin. Third is the generating the classes for the serial. So configure protobuf to generate the classes for the serializer. So what happens is, like, so whenever there is a protobuf, there is a serializer. So by the serializer. What does the serializer do? We'll come to know in the next slide. Now, defining the protofile. So for using the protocol buffer, you need to define a protofile. So protofile is nothing but uh, the schema which you will describe while saving your data. So let's suppose, let's consider a use case where I have a use case where I need to save user preferences in terms of, let's suppose, filters, right? So let's suppose I have a list and there is a user and there is basically some filters available in the screen, and probably I need to select those filters and probably save those filters the people, like the user has applied, and whenever user relaunches that particular screen, those filter needs to be applied back again to the list. So here you can see I have created a protofile, and the syntax of the protofile is you can see it in the official documentation of proto3. For the sake of this demo, I visit the proto3 syntax. You need to define your package name, and every preferences that you save comes with a message keyword. So I'll tell you the significance of the message keyword. So that message keyword starts with the add preference, add filter preference, and let's suppose there is an add type and there is an add category. So for all the types, you have all those enums defined. So it starts with 0 to, the numbers, positive numbers, and also, in a add category, the add category is also something. So something I want to save in form of data store. Now how will I do that? So let me jump to the studio again, so where I show you uh, okay, yes. So if you can see here, there is a creation step, so where I used to have that data store object. Now, if you compare the data store preferences with proto data store, there is one important parameter that is accept is basically the serializer. So this serializer will be generated at compile time. So the proto plugin that we added in our Gradle file, that is responsible for creating this serializer. So anything that you define in the message key, that message key is basically that message file, that message key would basically be used to identify that I need to create a serializer for this particular object, or probably the object that you want to store. So it creates a add filter preference serializer, and this serializer is nothing but it's a kind of, you can say, it's a kind of serializing the read and write operations on your input stream or probably the output stream. So this is something that a serializer performs. Is a normal serializer thing that we used to have in our daily objects. Second is basically saving value to the proto data store. So when you will save the data to the proto buffer store, what you do is basically you basically map your data. So you have to have a mapping for that, right? So now what happens is, let me go to the presentation now. Yep. So whenever you rebuild a project after having all these proto things set up, the add preference Java class is generated. So there will be class add filter preferences, and every message object that you give in a proto will basically be converted into your a class. Now creating the proto serializer. So every message object has to come with a serializer thing, right? So for writing and reading your data. So this is what you need to create your serializer, and these are very simple steps. Or probably if you want to read or probably have some encrypted or probably some secured preferences in your project, probably this is the place where you can modify it or probably manipulate it, and probably you can add it to your input order or read it from the output stream. So creating the data store, similarly, you pass on the serializer that you have created and the file name that is basically used to store the proto data store. Writing to the proto data store. So whenever you are, let's suppose, saving an add type, then what you do is basically you just check the type of the add, and probably you just map it with the preference.addType.3. So this is nothing but the generated file. So basically what happens when you compile your code, the message object in your proto buffer So that particular file is generated, and inside it you will be having the all the enums or probably that you have created. So you need to just map it to this, and you need to just save it to your, there is a builder function that gets created. So that builder function will basically, you will be setting the add type for it. So it's as simple as that. So now when this file is created, so you will see another file for proto data, proto buffer, that is basically add list preference.pb. So this is something, the file structure that it gets saved whenever there is a read or a write operations. Now again, while reading it from the consumer end, you again observe the flow, and you can see we can have all those. If there isn't any error, probably you can catch that, and also you can map it to your existing consumer behavior. So you can just apply those filters in your list. So this is something how you can read. So read operation is quite similar. Now the major part is basically how to migrate now from shared preference to data store. Now we need to pass a shared preference migration object to the data store builder. So what happens is, like, whenever you are creating a data store object, so right now we till now we have seen how we can create or probably set up data store in a very fresh project, in a very greenfield project, right? Now let's suppose we already have a shared preference in place. Now how we want to migrate? So the best part is, like, the data store gives us a default implementation for migration. So you need to pass a shared preference migration object to your data store builder. Data store will automatically migrate all the shared preference to data store for you. So migration should happen at very start before you basically access the data store. So all the shared preference needs to be migrated to the data store, and then you can easily use that after the migration is over. So it's similar to that of any migration that you do before your app start, or probably before you are accessing any preferences, right? Now, whenever you migrate from existing shared preference to proto data store, so what you will be having, you definitely need to have a mapping, right? Because right now for preference data store is very much simple. It's okay, but yeah, uh, for proto data store, you can just have a mapping in place along with the serializer, and you can basically do it. So for, as I told you, so you can pass a list of migrations to it. So there's a name of the preference file, that existing old preference file that you need to migrate, and there is a list of shared preference migration that you need to create. So just create an object and pass it, and rest of the things will be handled. Similarly, for data store, you need to have a mapping for that, because you need to convert your existing shared preference to that proto. So for that, you need to have a mapping for your proto data store. So this is how we create a shared preference migration. Along with that, you create a migration object. So add type will basically, you will transform the existing add type. It will read it from shared preference and probably convert it into the respective type for the proto data store. So there can be a list of shared preference migration, because your app might support multiple shared preference, and accordingly you need to write the mapper, and you need to create the data store. Moving ahead, so using data store in a synchronous code. So as I told in the very initial slides, it can be used as a synchronous mechanism, but yes, we should avoid using this. You can use the coroutine run blocking builder to basically run the data store in a synchronous manner. Or what you can do is asynchronous preloading you can do. So what you can do is you can asynchronously load the data store, and after the load is performed next time, because since the data will be cached, so whenever you do a synchronous operation, there will be no hit on the performance. So you can directly have a asynchronous preloading in place. So if you want to execute or probably read the data store in a synchronous manner in your existing app. So that's it. So thank you, and say hello to DataStore and buy the age-old shared preference. So these are some of the references that you can refer for this particular topic. I will upload. I've already uploaded my slides in the speaker deck, and also for the protobuf guidelines, you can visit the official Google guidelines. Also, there is a GitLab demo, or probably a demo that is available, that I've used for this particular demo. You can go and probably take a photo of it, and probably play with the playground. Okay, so this is me. Again, I lead the Android team at ORX, and you can find me either in Medium or probably you can follow me in Twitter. I'm in LinkedIn, or probably you can mail, or any medium I am available. Thank you very much for attending this session, and have a nice day ahead. Probably I can take up the questions. Okay, I can see one question. Is data store secure? Does it have, okay, okay. So does it have some alternative of encrypted shared preference? Okay. So encrypted shared preference, if I tell you, like uh, for preference data store, it's the same. Inbuilt encryption is not provided. Like we don't have any kind of inbuilt encryption preferences. But yes, you can use the same encryption logic that you have been using in shared preferences. You can use that, and probably you can play with the serializer where you can have that, like encryption decryption mechanism over there, and you can use that. So it's, you can use that and you can leverage that thing. So can I go to the next question? Yes. So data store can be used in production state. So right now it's in alpha, and Google is continuously, like publishing updates to it. Probably we need to wait for some time more where we can, like find a very stable version and we can have it in production. Yeah. So moving ahead, where can I get this GitHub link for this project? Okay, so I'll be sharing this link in the platform in my profile. You can go and probably already, I have already published the GitHub link for this project. You can go and probably play around that project. Any feedback, please let me know over all the Medium channels that I have published. Can data store be used in Java code? So I have not tried in Java code, but yes, coroutines, it needs to support coroutine because it returns a flow and you need to read that flow. So I think, and again, like coroutine is something that Kotlin is something that yeah, Google is also preferring as a first language. So I think it's better that we move to Kotlin and then we use data store. Yes, so that will be very much convenient. Okay, thank you very much, guys, for attending this. Have a nice day ahead.